Alright, good morning. We are going to be deriving exponential functions today from word problems. So, our exponential functions are y equals ab to the x, where a and b are constants, and x and y are the independent and dependent variables. So we are going to be using the information we're given to find a and b, and then we can plug them into our exponential function. So the first problem we're going to work is the punctured tire problem. On your way home from school, you run over a nail. The pressure in the tire decreases exponentially with time since you ran over the nail. After 4 minutes, the pressure has dropped from an initial value of 36 psi to 18 psi. So to write the equation, I'm going to need to first define my dependent and independent variables, my x and my y. My independent variable here is going to be time, and we're measuring that in minutes. My dependent variable is going to be the tire pressure, and that is being measured in psi. So what I'm going to do is use that information I was given to get xy pairs and use that to write my function. So an initial value of 36 to 18. Well, that means that at time 0, before I ran over the nail, my tire pressure was 36. Then 4 minutes later, my pressure is 18. So those are my two ordered pairs, x, y's. So what I'm going to do is plug in the x and y into my exponential function and solve for a and b. So we're going to use 0, 36 first. I'm going to plug in 36 for y and 0 for x. So that means 36 is equal to ab to the 0 power. Well, anything to the 0 power is 1, so that means 36 is equal to a times 1, which means a is 36. Now that I know A, I'm going to use that and my second pair to find B. So for this pair, y is 18, so 18 is going to equal 36 times B to the 4th. I'm going to solve this for B. So at first I divide both sides by 36. That's going to give me 1/2 is equal to B to the 4th. So to get rid of my 4th power, I'm going to take the 4th root of both sides, and this is where I'll need a calculator. So 0.5 to the 1/4 power, and I'm just going to round to 2 decimal places, and I get 0.84. So my function is y equals 36 times 0.84 to the x power. Now, if it takes me 12 minutes to drive home from school, find the psi after 12 minutes. Well, after 12 minutes, that means x is 12. So I'm going to plug 12 into my function and solve for the pressure. And again, you will need a calculator to do that calculation. And that's about, oops, I did a decimal point too far. There we go, about 4.4 psi. So, will you make it home before the tire pressure drops below 5 psi? No, because when I get home, it's 4.4. I've justified my answer by doing this calculation. Okay, one more example is this bacteria growth problem. The number of bacteria per square millimeter in a culture in a lab is increasing exponentially with time. On Tuesday, there were 2,000 bacteria per square millimeter, and on Thursday, it had increased to 4,500. So again, to derive my equation, I'm first going to define my independent and dependent variables. Here, x again is going to be time, but now I'm measuring it in days. And y is going to be bacteria, and we're talking about the number per square millimeter. So again, I need my two xy pairs. On Tuesday, my starting day, there were 2,000. So that's going to be 0, 2,000. Then Thursday, which would be 2 days later, it is 4,500. So again, I'm going to plug in the xy pairs. I'm going to do 0, 2,000 first. Anything to the 0 power is 1. So that means A is 2,000. So I'm going to use that. And this other ordered pair, 4,500, is going to be equal to 2,000 times B to the 2nd power. So I'm going to divide 4,500 divided by 2,000 is 2.25. And if that's equal to b squared, I'm going to square root both sides. And b is actually a pretty number this time. It's just 1.5. So my function is y equals 2,000 times 1.5 to the x. So how could I predict the number of bacteria that will be in the culture on Tuesday of next week? Well, Tuesday of next week is 7 days later. So that means when x is 7. So I'm going to plug in 7 for x into my function. 1.5 to the 7. Again, I'm going to use my calculator. And so just rounding to the nearest whole number, that's about 34,172 bacteria per square millimeter. Now, how can I predict the time when the culture reaches 10,000 bacteria? Well, that's saying when y is equal to 10,000. So I'm going to plug in 10,000 to y in my function. And I'm now going to be solving an exponential equation, which means I need my exponential by itself. So I'm going to divide the 2,000 on both sides. So this becomes 5 equals 1.5 to the x. Now I can rewrite it as a log. Log base 1.5 of 5 is equal to x. This is where I need my calculator again. And so x is about 4. So 4 days later from that first Tuesday would be on Saturday. So when you only have 2 data points, you have to solve them by hand like this. But if you are given multiple data points in a table, you can actually have the calculator do the regression for you. And that's what we are going to practice next. So again, we still are looking for y equals ab to the x. And these are the steps we're going to follow for these 2 examples. So the first one is a car depreciation problem. So I've initially purchased a car for $15,700. X is time in years, and y is the value of car in dollars. We want to write the exponential regression equation for this data. So I'm given this table already where I have my set of x's years and y's dollar value of the car. So what we are going to do is hit the stat button on your calculator, which is right here next to delete, and you're going to hit edit, that first option. So you've got all these L1, 2, 3, 4, 5, those stand for lists. So what you're going to do is put your x values in list 1. So 0, 1, 2, 3, 4, 5, 6. And then you're going to put your y values in list 2. Okay, then you're going to exit. We're going to go to stat again, this time arrow over to calc, and go down to option 0 where it says exponential regression. Then you're going to hit enter 5 times. And what this has done is it's told me this is my a value and this is my b value. So we're going to plug those into my exponential formula. And this instructions tell us to round to the nearest hundredth. So y is going to be equal to 15,865.20 times 0.90 to the x power. How could I find the value of the car after 9 years? Well, that just means when x is 9. So with your calculator, you're just going to do that calculation. 65.2.9 to the 9th. And if we're talking about value in money, we're going to be rounding to the nearest cent. Okay. Let's do that one more time with this bacteria growth problem. Again, we're doing bacteria culture over a 5-hour period. So we have this data table with our x being time in hours and y being the number of bacteria present. So following those same steps, we're going to go to stat edit. And I have one less data point here. So what I can do is just go down to that one I don't need and hit delete. And then I can just hover over the other values and replace them. Okay, then again, stat, calc, exponential regression, hit edit 5, or excuse me, enter 5 times. There's my A, there's my B. So that's going to be 903.30 times 1.09 to the x. To find the bacteria after 14 hours, that is just going to be when x is 14. And that's going to be about 3,019 bacteria. So again, an exponential regression only works when you have multiple data points, like at least 4 or 5. When you only have 2, you have to solve them by hand like we did on the back side of this page.